This is problem 15.75 on page 1032. A helicopter moves horizontally in the x direction at a speed of 120 miles an hour. Knowing that the main blades rotate clockwise when viewed from above with an angular velocity of 180 RPM, determine the instantaneous axis of rotation of the main blade. So let's draw this helicopter from the top down. They made an XZ coordinate system with Y coming out this way. Let me just draw some blades here. And the rotation direction, omega, is clockwise. They told us that the rate of rotation is 180 revolutions per minute, and that the center of the helicopter is moving forward with a velocity of 120 miles per hour. Now you might look at this and you might say, well, I know where those blades rotate. I know where their center of rotation is, right there where there's an axle. Maybe relative to the helicopter, but not relative to ground. Think about it this way. If the helicopter is moving forward while these blades rotate this way, any point out on this blade is going to end up moving faster than 120 miles an hour. Because not only is the helicopter moving forward, but also the blade is rotating, so that any tip of the blade is moving faster. On the other hand, this side of the blade, if the helicopter is moving forward, the blade's moving backward, any point here is going to be moving slower. So there must be some point out here that when the blades end up in this configuration, there must be some point out here where the velocity goes to zero, right? There must be some point where at that instant in time we could have put a pin in that blade through the blade to ground, and it would be rotating about that point. Okay? So basically what we're going to do is try to figure out how far out that point would be. Alright, well, we know the velocity of the helicopter is 120 miles an hour, so if I can find a point out here that's moving 120 miles per hour in the opposite direction, well, that's going to cancel out the forward motion of the helicopter, and that would be the location of the instant center. So the relative velocity relative to the helicopter, the relative velocity of any of these points is going to simply be omega times r, where r is the distance from the actual center of rotation on the helicopter out to the instant center. Okay? So I'm looking for a point, r, where with this rotation speed of 180 revolutions per minute, I find a relative velocity of 120 miles an hour. So basically what I'm going to do is solve this equation for r, that would be the relative velocity divided by omega, plug in the numbers, and find the radial distance where I get 120 miles an hour. So let's see, 120 miles per hour divided by an angular speed of 180 revolutions per minute. You see we've got a whole lot of conversions to accomplish here. For example, there's 1 hour per 60 minutes. That way all the time units are gone. And revolutions don't play well with others, so let's go to radians. There are 2 pi radians per revolution, and that way the radians go away for free. And this will tell us how many miles out on the blade that point is located, but I probably don't want to measure it in miles. I'd like to measure it in feet. So let's convert 5280 feet per mile. And this should tell us how many feet out on the blades is the location of the point that is the instant center of rotation, a point that is not moving relative to ground. Okay? Take your calculators, please, and plug in all of this mess and let's see what we get. 120 over 60 is just 2. So that's going to cancel. 120 and 60 will cancel with the 2 in the denominator. So basically we need 5280 over pi over 180. What do we get in that case?
9.337.
So that's how far out on the blades we'd have to go to find a point that doesn't move relative to ground. What if this helicopter is a little toy helicopter? It's moving 120 miles an hour with this rotation speed, and the blades only measure 3 foot radius. Well, there is no point that's moving. No, yes, there is. We always consider a body to be as large as we need it to be in order to locate a point on that body, even though the body doesn't have any material there, because we're interested in motion. We're interested in how this motion occurs. That's what we're doing. We're studying motion kinematics. And so remember, we can always extend a body to include points that it doesn't really include. Okay? So if the blades had material out here at 9.337 feet, that's the point that has no velocity relative to ground. Okay? Any questions about this problem? It's pretty easy. All right?